The markings allow you to see the bevel orientation, which can sometimes be challenging to see on fluoroscopy. So if you're concerned where that bevel is and you want to try to go around a bend and keep your bevel open face to the vena cava, it gives you the ability to have a great deal of confidence as to exactly where that bevel is at any given time.
Once you've advanced the inner sheath a certain distance, then you put the outer sheath over it, you'll see the marker to tell you that the two tips are aligned inside the patient's body. Additionally, you have a marker that shows the orientation of the bevel. And that's helpful so that you can rotate the bevel to the inside of the curve as you advance down into the vasculature. It's terrible to run out of sheath, and that can happen sometimes. So if you have a sheath that's too short, next thing you know, you're handling the sheath right at the clavicle and you have no more flexibility. You can't advance it any further. So having a sheath that's longer gives you that option to be able to maintain control outside the patient's body and not have your fingers right up against the clavicle while you're advancing down into the right ventricular apex. And sometimes you have to advance these sheaths all the way into an RV apex of someone who's a large patient, who has a large heart, and use up all the sheath if it's too short.
With the lowered resistance within the sheath system, it allows easier rotation of that inner sheath relative to the outer sheath. This is going to give the operator better feel for what's going on, better feel for how much of the pressure one is putting on the inner sheath is actually being transmitted down the length of the vessel across the lead to where the binding site is. So it's nice to have a system that moves nice and fluidly, easily. If you have less binding in the sheath, less friction in the sheath, it's going to make the procedure easier on the operator.